Binomial expansion. That sounds pretty terrifying, doesn't it? However, binomial just means 2. Instead of using the distributive law with one thing outside the brackets, instead we have 2 things outside the brackets. Seems a little bit less scary now, doesn't it? With the distributive law, we share something equally between everything in the other brackets. So we're going to do the same thing here. We have an x and we have a 6. We have an x and we have a 2. Let's share this x between the x and the 2. But we also have a 6. And we've got to give the 6 to both the x and the 2 as well. And just like before with the distributive law, we're just going to times each one of these arrows. Let's work out the x first. X times x is the first one. Then we have x times 2. And then we have 6 times x. And we also have 6 times 2. Then all we have to do is simplify this long expression. X times x is x squared. X times 2 is 2x. Six x is the next one. And then 6 times 2 is 12. That's all there is to binomial expansion. As I said at the start of the video, it sounds scary, but it's really not. Just draw your arrows from the first thing to the others, and then from the second thing to the others. And then just multiply out. Just be careful when you're expanding into something so long that you don't forget something. Lastly, with this example, we could then simplify 2x and 6x. 2x plus 6x is 8x. In the end, we would end up with x squared plus 8x plus 12. That would be the simplest answer we can get. Let's do a couple of examples so we can better understand binomial expansion. Sometimes when we're expanding binomials, we will have a number out the front. This is just like the distributive law before. You just times the number out the front by the 2 things next to it. However, I'm going to multiply that 4 last, because that's going to make everything else 4 times bigger. So let's expand our 2 brackets first, then we'll make everything bigger. The bigger the numbers are, the more time consuming and the trickier it can get. So let's keep things simple. We have 2 minus u and 5 minus u. Those are the 2 things in the brackets. So let's expand these brackets and see what we get. What does this expand out into? 2 times 5 and 2 times negative u. And we also have negative u times 5 and negative u times 5 and negative u times negative u. and negative u times negative u. While I'm going through this example, you can see that I'm writing a plus every time, and then I'm actually using the negative u there. I'm not trying to work out if it's positive or negative until the end. This is a good trick so that you don't accidentally forget a negative. Right, let's simplify this. 2 times 5 is 10, plus negative 2u plus negative 5u plus u times u. U times u is u squared. And we have a negative times a negative, so it's going to be a positive. The last term is u squared. Now we have 10 minus 2u plus minus u plus u squared. Now we have some like terms we can simplify. Minus 2u plus minus 5u, well, that's the same as negative 2u take away 5u, which is negative 7. So 10 minus 7u plus u squared. Now that is our brackets, but remember, we have this 4 out the front. Let's expand this last bit. 4 times 10 is 40. 4 times minus 7 is negative 35. U. And lastly, we have 4 times u squared, which is just 4u squared. Here we have 3 things times together. In maths, when we times 3 things together, that reminds us of a formula. That formula is a cube. We have length times width times height. So when you're dealing with binomial expressions like this, you might be asked to work out the volume of this cube. All you do is you multiply the length by the width by the height, just like what we've done up here, and you'll get the answer. This is the answer. We don't know what u is, but that means that that box over there, could be any size. And that would be the volume. In this example, we're missing our second bracket, but we do have the answer. When we are expanding binomials, the easiest way to figure out what we're missing is to have a look at the number that's at the end and have a look at the pronumeral at the front. So over there we have t squared. What would we times t by to get t squared? Well, we would have to times t by t to get t squared. Let's just write that there. T times t equals t squared. The thing in the middle is a combination of 4, our number 2, and t. So that one's a little bit tricky to work out because there's a combination in there. When we expanded our brackets over here, you can see that we ended up with 2 things with a number and a pronumeral. But we only ended up with 1 thing that only has numbers and 1 term that only has pronumerals. So we figured out our one thing that has only pronumerals. What about this thing on the end, our 12, our negative 12? We have minus 2. Now what would we times minus 2 by to get negative 12? We would times by 6. We think that our two missing things are t and 6. So let's try to find the middle term to see if we're correct. Now, the middle term is a combination of this pronumeral and the other number, plus this number and the other pronumeral. So that thing in the middle ends up being t times something plus negative 2 times something. Now we think those two somethings are t and 6. So let's pair our pronumeral with our number and a number with our pronumeral. So t times 6 is 6t plus negative 2 times t. So minus 2t. 6t minus 2t is 4t. When you're looking at a problem like this, look at the thing with the squared on it. Have a look at the number that's by itself. And then see if those two numbers that you found and pronumerals that you found fit into that middle term. So good luck with those questions, and I'll see you in the next video.